Once again, welcome back to geometric design of highway. In this video tutorial, I will go through vertical alignment type B, that is for valley curve. B, valley curve. A vertical curve having concavity upward or convexity downward is called valley curve. The figure shows that how the valley curve is formed. For example, when the descending gradient meets the ascending gradient, there will form a valley curve. Similarly, when a descending curve meets the level road, then there will form also a valley curve. Similarly, when a descending gradient meets another descending gradient, there also form a valley curve. Now, for the design of valley curve, that is the determination of length of valley curve, we have two criteria. The first criteria is the rate of change of centrifugal oscillation C equals to 0.6 meter per cube second, and this is the typical valley curve. In this valley curve, we use two transition curve from A to B and B to C. Here, A to B is one transition curve, then B to C is another transition curve. Therefore, the length of the valley curve, for the consideration of rate of change of centrifugal oscillation, length of valley curve is twice of transition curve, that is LS. The length of transition curve for comfort condition is given by LS equal to PQ by RC, that we have already derived in transition curve video lecture. Therefore, the value of R, that is the value of R at the length LS is, then the value of R, that is the radius at B point, is LS by N. That is, LS is the length of the valley curve, is the LS is the length of transition curve, that is A to B. That is, the LS is the half of length of valley curve, that is L by 2. Therefore, R at B point is L by twice N. Therefore, LS equals to PQ by C, that is putting the value of R equals to L by twice N. In that relations, we get this equation. There, that is the LS equal to, and final, the length of transition curve equals to S equals to NP cube by C whole power 1 by 2. Therefore, the length of the valley curve is twice of transition curve, twice LS equals to whole bracket NP cube by C whole power 1 by 2, where N is the deviation angle, P is the design speed in meter per second, C is the allowed rate of change of centrifugal oscillation and taken as 0.6 meter per cube second. The minimum radius of the valley curve for the cubic parabola is given by R equals to, where R equals twice, N by twice L. There should be R equals to L by, there should be R equals to N by twice L. Then the second criteria is headlight side condition. For headlight side condition, first we assume the length of the valley curve is greater than stopping side distance. Here, this is the length of the valley curve, and the side distance is the distance clearly seen during the headlight light dispersion, that is the S is the clearly distance seen by the driver during night driving. Then y equals to ax square, where y equals to a by a equals to n by twice L. Then y. Your y varies, that is y equals to h1 plus s tan alpha equals to a equals to n by twice l, and s is the side distance s square, where h1 is the average height of the headlight, that is 0.75 meter, and alpha is the vertical light dispersion in vertical plane, that is taken as 1 degree. Therefore, length of the valley curve for the headlight condition equals to L equals to n s square divided by 1.5 plus s into 0.335. Similarly, when the length of curve is less than stopping side distance, here the side distance is larger than this curve length, then for this relations we use the h1 plus s tan alpha, that is h1 plus s tan alpha is the angle component of this distance remaining, that is the s minus ls, that is s minus ls into n, and the final calculate the relations L equals twice s minus twice h1 plus twice s tan alpha by n, h1 equals 0.75 and alpha equals to 1 degree. And for the lowest point on vertical curve, valley curve, we need the lowest point on valley curve for the drainage consideration as well as for the crossing structure placement on that valley curve. In symmetrical valley curve, that is symmetrical equals to the grade n1 must be equals to n2. For the symmetrical valley curve, the lowest point on the curve will be this angle bisector line cuts the curve. The intersection point of curve and the angle bisector is the lowest point on curve for the symmetrical curve, that is the n1 equals to n2. Then for second criteria for the lowest point when the curve is asymmetrical, that is n1 is not equals to n2. This is a typical example of asymmetrical curve where n2 is flatter than n1. In this case, the lowest point lies along the side of the slope, flatter slope, that is n2. In this figure, y1 equals to ql equals to qs minus ls, that is y1 equals to ql equals to n2 x1 minus b x1 cube. Now the point L will be the lowest point when y equals to ql is maximum. For the maxima and minima, we have the first derivative of y equals to 0, and the calculator is n2 minus 3 x2 square b equals to 0. Then solving these equations, we get the x1 direction equals to root under n2 divided twice b. Then the solving final equations, we get the x1 equals to root under n2 l square by twice l. That is the lowest point lies on the flatter slope at a distance of x1 from the vertical tangent point of flatter slope. That is the x1. That is the x1 is calculated as, that is the x1 is calculated as capital L is the length of valley curve, root under n2 by twice n. That is the lowest point lies on the flatter slope at a distance of x1 from the vertical tangent point of flatter slope. Now example, design the length of valley curve at the junction of descending gradient of 1 by 40 and ascending gradient 1 by 30. If the design speed is 100 km per hour, so as to fulfill both comfort condition and headlight side distance for night visibility. Locate the lowest point to calculate elevations. If the elevation of the beginning of the flatter, that is the beginning of the valley curve, is 100 km per hour, then the elevation of the headlight side distance for night visibility is 100 km per hour. Then the solving final equations, we get the x1 equals to root under n2 divided twice b. Then the solving final equations, we get the x1 equals to root under n2 l square by twice l. That is the slope along the flatter slope is 312.56. Solution. Then the deviation angle is calculated as n equals to 7 over 120. As in given question, stopping side distance is not given, so we have to calculate the stopping side distance from the regulations, and it's calculated as 182 meter. Now for the determination of length of valley curve, for the first condition, night visibility consideration, we use the relations L equals to n square by twice h1 plus s tan alpha, and it's calculated at 215 meter. And for the comfort conditions, we use these relations and calculated as length of valley curve round about to 220 meter. And for the lowest point, since this is the asymmetrical valley curve, since the descending gradient and ascending gradient doesn't seems to be equal, therefore the lowest point lies at the flatter slope, that is a 1 by 40. Then the lowest point lies at a distance x from the vertical tangent point at the flatter slope, that is x is calculated as 250, that is the length of valley curve root under flatter slope n2, that is n2 flatter slope 1 by 40, and twice n, capital N equals to deviation angle 1 by 120, and it's calculated as x is calculated as 115.73. that is the lowest point on the vertical curve lies at a distance of 115.73 meter from the vertical tangent point along the flatter slope. Then the y equals to ls is calculated as bx cube, where x is the distance from the tangent point, that is calculated as 115.573, and b is twice n divided by 3l square, and it's calculated at 0.96 meter. Therefore the length of the lowest point L is 312.56, that is the elevation of tangent point T2 minus minus QS, that is QES is calculated as N2x. N2 equals to 1 by 40 into, this must be multiplication, 115.73 into 1 by 40, then plus LS equals to y equals to 9.6, and the elevation of lowest point is calculated at 310.62 meter. If you like this video tutorial and lectures, please like, share and subscribe my channel for more lectures, tutorial and solution. Thank you.